So now we're going to talk about data trend approximations using plotted points only. Now, here we have a graph where the horizontal axis represents height in meters and the vertical axis represents weight in kilograms. Now, I am going to draw here by connecting these points. Hopefully you notice that when I connect 2 points on this scatter plot, not all of them have the same slope between each two set of points. So this tells us that it's not quite linear, but it's approximately linear. So we would, if you look at the third question, it says, what function type would this be? Although, again, it's not exactly linear, it is approximately linear. So that's what we would use to model this. Now, the first question asks, what is the trend for this data? And the trend is positive or increasing since the data points are going up in an upwards trend. And hopefully you've seen that in real life. When you were a kid, as your height grew, so did your weight because you were getting taller. Now, I am going to attempt to draw a line that is as close as possible to all of these points. So there is my best attempt at creating a line. Notice that it doesn't go through all of the points. It goes through some of them, not all of them. I tried to make it as close as possible. So when it asks what is the average rate of change, we're going to use this line now, and I'm going to call it the line of best fit. And I'm going to choose 2 points on the line to calculate the average rate of change. So I'm going to use this point right here and this point right here. So the first point that I've kind of highlighted, I want to write an ordered pair for it. So it's nice that the first coordinate looks like about 1.5, and then the second coordinate, let's see, it looks like it's starting at 50, 51, 52. It looks like that is 53. So 1.5 comma 53. And then there is that. Okay, so it's looking like that is 72 there. So this next order pair, I believe, is going to be 1.8 comma 72. Now, when we calculated rate of change or the slope with linear functions, we used the formula m is equal to y2 minus y1 over x2 minus x1, which is essentially what we're doing here. So if this was my x-axis and this was my y-axis, then I could call this one x1, y1, this one x2, and this one y2. So average rate of change is equal to y2 minus y1 over x2 minus x1. And if I pull out my handy dandy calculator, we have 72 minus 53, which is 19, divided by 1.8 minus 1.5. So that is approximately 63.3 repeating. And what is the units on that? Well, the y-coordinates represent kilograms and the x-coordinates represent meters. So 63.3 kilograms per meter. So all that's saying is that as the height grows by 1 meter, then on average the weight gained is 63.3 kilograms. The first question for this next scatter plot says, what is the trend for this data? And we would say either a negative trend or a decreasing trend, since the pattern is that the data points are going in a downwards direction. And what function type would this be? Again, it is approximately linear. The previous scatter plot was definitely closer to being linear than this one is, but it's still, the general direction is kind of a line. And so once again, I'm going to try to get my line as close to all of these points as possible. Again, notice that it's not going through all of them. And so there are definitely more points that are farther away from this line that we've created again. So again, I'm just going to try to pick 2 points that I see on this line. So one of the points I will highlight right here, and then another point maybe right there. So the first point, if I pull that up, I'm going to approximate that to the best of my abilities. So that's looking like 1, 7. And then this one here, that one is looking like 8, 2. And so if we were to similarly calculate the average rate of change like we did last time, I'm going to label my 2 ordered pairs with x1, y1 and x2, y2. And then my average rate of change will be equal to 2 minus 7 over 8 minus 1. So that is negative 5 over 7. So notice here that there's no units on either of the axes, so we don't quite know exactly what this is measuring, but we do know that for every for every 5 of the x, whatever x is measuring, as you increase by 5, the y value is decreasing by 7. All right, for this next one, we are going to say that the trend is increasing or positive. Now, again, I'm going to answer the third question next, and there are really 2 ways you could kind of answer this. So this could potentially be logarithmic, in which it would look something like that, or it could also be quadratic, because our graph could look something like that, and then it could go back down in a downwards direction like that. But because we only have a limited number of data points, we really can't, it's difficult to make that distinction. And so for the third question, what function type would this be? We could really say logarithmic or quadratic. And it just really depends. We don't maybe have enough information to make that conclusion. And then the other thing is, because it's not linear when it's asking for the average rate of change, normally what we do is we take the average rate of change by taking 2 points on the model. And so maybe I would choose, let me use a different color here. So I have my model here, whether it be logarithmic or quadratic. And normally we calculate the average rate of change by picking 2 points on the model and connecting them with a line and then calculating the slope of that line. So here I could potentially do that, but because no 2 points are specified in this second question, it's hard to decide which 2 points I would be choosing since it's not linear and it's curved. So because, again, there's no interval or points information given, no interval given, we can't really calculate the average rate of change in this scenario.